this video, we want to talk about how to solve for this circuit right here. Remember, we solved for this circuit previously, and we solved for, this equation here, 10I1 plus 5I2 is equal to 10. Again, you have I2 minus I3 is equal to 0, and then I1 is equal to I2 plus I3. How do we solve that? Okay. Now, we're not math majors. We don't reduce as much. We're more about efficiency and speed. We're really not about every single protocol of math, right? So I want to show you how to do this in a little faster way. Okay. So what you want to do is take this equation here, right, and write them down. So this equation here, which is 10I1 plus 5I2 equal to 10, is write it here, right? 10I1 plus 5I2 is equal to 10. This becomes I'm going to call this equation 1, okay, E1. Now, this equation right here, I2 minus I3 is equal to 0. I2 minus I3 is equal to 0. This is my equation 2, okay? And now what I'm going to do is I1 is equal to I2 plus I3. This is my equation 3, okay? Equation 1, equation 2, equation 3. How do I solve it? Well, first thing you'll notice is you want to flip this into x, y, and z. So what I want to do is, if you're not used to dealing with I1, I2, I3s like that, simply state x is equal to I1, y is equal to I2, and z is equal to I3. Okay? When you do that, your equation 1 now becomes what? 10x, because I1 is x, plus 5I2, which is y, is equal to 10. Now this becomes a little friendlier. I2 is equal to y. I3 is equal to z. Minus z is equal to 0. Okay? Then I1, which is x, is equal to I2 plus I3, which is y plus z, right? Now this becomes more friendly. It's more like the algebra that you used to do, right? So how do I do this? Well, the easiest way to do it is basically you've already set it equal to each other here, right? X equals y plus z. So wherever there's an x, I simply plug in a y plus z, right? So this is equation 1 again, right? This is my equation 2. This is my equation 3. Let me draw the arrows here to make it more consistent so that you see where it's coming from. Okay? So here, equation 1, equation 2, okay. So from here, you write this out. This is the second step. So now you said x equals y plus z. So you want to plug in x, right, into here, right? So equation 3 goes into equation 1, right? And you plug in the value for x. So here you get 10x, which is now y plus z plus 5y is equal to 10. My equation 2, right, is now what? My equation 2 is y minus z is equal to 0. Right? So this is kind of, you have to kind of separate this out a little bit. And so kind of go through everything a little step. Okay, here. Once you're able to plug that in, now you can see the equation formulate, right? So this will give us now what we're looking for. 10y plus 10z plus 5y is equal to 10. Okay, which gives us the following equation, which is equal to, and this is our, again, it's our equation 1, is we want to call it 15y plus 10z is equal to 10, right? And then we can just say this, reduce this easy out by divided by 5. So I get 3y plus 2z is equal to 2. You divide by 5, so we'll divide this by 5. Okay, that's how I did it, right? So you have, this is your equation 1, and then you have your equation 2, which is y minus z is equal to 0. Now you can see this is easily coming out. There should not be any problems in this, right? So what we want to do is we want to go ahead and solve for this. So I'm going to erase this real quick, and I can solve for this very easily. Okay, and this is my equation 2. Now I have to start eliminating. I have to eliminate now this equation and this equation. I'm going to deal with these two right now. Where it gets a little messy, but you'll catch up. So I need to multiply this something to get rid of this. So I want to eliminate on one side. I want to eliminate y, and the other side I want to eliminate z, right? So how do I eliminate y? Well, I have to multiply 3 by the top and bottom, right? So if I multiply 3 across here, right, and 1 across here. So this is how we do it. We write the equation 3y plus 2z like such. Okay, just like that. And so what's in front of the y? If I want to eliminate y, what's in front of that y? That's a 1. What's in front of that 3? That's a 3. Gives me what? 3y plus 1 times 3 is 3, 1 times 2 is 2z is equal to 2. 3y minus 3z is equal to 0. Now, what do? I have to get a minus 3 out of it somewhere, right? Because 3 minus 3, if I want to eliminate it, one of them has to be a negative. So I'll just stick a negative sign in front of there to make things easy. So this way this becomes a negative, this becomes a positive, and that becomes 0. So I get what? Y eliminates to 0, and I get 5z is equal to 2. Z is equal to 2/5, or roughly 0.4. Okay? Now this side, I eliminate z. How do I eliminate z? Okay, so let's kind of draw a line in the middle to kind of make things easy. Right? So now I draw a line in the middle. I'm going to eliminate z. So I say, or I write the equation, 3y plus 2z is equal to 2. Now my z's are always crossed, so because you've got a lot of z's and a lot of 2's. Y minus z is equal to 0. Right? What do? Well, I want to eliminate z. So what I need to do now is multiply the top by, there's a negative in front of there, -1, right? But we can just assume it's a 1, see what happens. Forget the negative sign. There's a 1 in front of that z, and there's a 2 in front of that. Okay. That gives me 3y plus 2z is equal to 2. This gives me 2y minus 2z is equal to 0. Okay. Notice I didn't have to multiply anything out. It just came out. So this eliminates out to 0. I get 5y is equal to 2, right? So y is equal to 2/5. Again, y is 0.4. Okay. So we're going to probably have to go to the next page to solve it. It won't require much. Okay. So now that we have our z, our y, and now we need our x. Okay, so we say x is equal to, from here, x is equal to y plus z. So that is 0.4 plus 0.4 is 0.8. Okay, so x is now equal to 0.8. Okay, so what does that mean? Well, let's go back to our original equation, right? Let's go back. X is equal to I1, Y is equal to I2, Z equals to I3. This is just a lot of work. This is not very difficult, but it is rather time consuming, especially on an exam. You don't want to be stuck on this on an exam, right? You want to get the answer quickly. But anyway, so I1, X is equal to I1 is equal to X, which is equal to 0.8 amps. I2 is equal to Y, which is equal to, down here, Y is 0.4, so that's 0.4 amps. Z is equal to I3. I3 is equal to Z, which is equal to 0.4 amps. As you can see, if you put this entire problem together as we first started, right, it will take you 3 pages. Okay, 3 pages to solve the circuit. 1 page to set it up, and then roughly 2 pages to solve the math. Okay, and unfortunately, this is time consuming. So in our next video, what I'm going to show is how to get this answer very, very quickly.